Hey guys, this is 5.2. We are going to take everything we learned from 5.1 and we're going to apply it to graphs. So we're going to find the y-intercept, the x-intercepts, the end behavior, the number of turning points of each polynomial function. And using that information, we're just going to draw a quick graph of each one. Okay, and I think there are 5 examples today. Oops, sorry. I wanted that one. All right. So example 1, part A is f of x equals 3x plus 1 times the quantity x minus 2 squared. So let's start by finding the x-intercepts of this function. I'll start down here. Okay. So we have f of x is 3x plus 1 times x minus 2 squared. We're going to find the x-intercepts, which are also the real zeros. So I'm also just going to call them r. Okay. And remember, r is x minus, sorry, each factor is x minus r. Okay. So for the factor 3x plus 1, we're going to use that to solve for x. What would x be? So that would be 3x is -1. So x is -1/3 for that first factor. Okay. And then we're going to look at this exponent right here to find out its multiplicity. I'm just going to call that m. It has a multiplicity of 1 because it's an understood 1. Multiplicity of 1. 1 is an odd number. And so remember, every odd multiplicity crosses the x-axis. Okay, so we have an x-intercept where the graph crosses x at -1/3. That's our first x-intercept. We have one more at x minus 2 squared. So that's a little bit easier. We're not going to have to do x equals. We can immediately go to x equals 2, right? Because if I set that equal to 0 and I said x minus 2 equals 0 and I move the 2 over, it would just say x equals 2. The multiplicity here is 2 because it has an exponent of 2. 2 is an even number. And even numbers mean they touch x but do not cross. Okay, so it's kind of like you go up to the x and you come back down, or you go down to the x and you come back up, where cross is just a line straight through the x-axis. Okay, so those are our 2 x-intercepts. We have an x-intercept at 2 where it touches and an x-intercept at -1/3. Now let's find our y-intercepts. Our y-intercepts are also our constants. Here we have a +1 and a -2 squared. So we have 1 times -2 squared is our y. That would be 1 times 4, which is just 4. So our y-intercept is 0, +4. Okay. So that's our x-intercept, that's our y-intercept, and then we have the leading term. So we need the leading term. The leading term will tell us the end behavior and the number of turning points. Okay. So for the constant, we just multiplied the last numbers, right? Any number without an x, we multiplied together to get the y-intercept. It's just a shorter way than foiling to find it. So for our leading term, we have our first term. So we have 3x to the first and we have x to the second power. So that would be 3x to the third is our leading term. Okay. If I had FOILed out the entire factored equation, 3x cubed would be my leading term. We need to look at this number. If this number is positive, which it is, 3 is greater than 0. So the ends go up to the right. Okay. Whatever happens to the graph, it ends with an up arrow. Now we need to look at the exponent. The exponent is odd. That means that the ends go in opposite directions. So if this one goes up, this one's going to start down. Okay, and finally, 3 is going to give us the max number of turning points. 3 minus 1 gives us the turning points of 2 or fewer turning points. So for the end behavior, we use the first number to decide if it's up or down to the right. And we use that exponent to decide whether they go in opposite directions or the same direction. And then we subtract 1 from that exponent to find the number of turning points, the max number of turning points. Okay. So now that we know where it crosses, where it touches, where it crosses, and whether it goes up or down to the right, we can graph this. Wow, those are horribly spaced. All right, we know it crosses y at 4. We know it touches x at 2. So I'm going to put a t here so I know it touches. And then it crosses at -1/3. We know that it's going to go up on the right side, and then it's going to be going down on the left side. And that it should only have 2 turning points, okay? So we're just going to start here, cross, up, touch, up. All right. Now let's see if Desmos agrees with us. Does that look like mine? Yes, close enough. Theirs is much more beautiful, but it crosses at -0.3 and it touches at +2. It crosses the y at 4. It has a height of 5.6, which we could not really have known, but we got the rest of it. All right, so that's part A of example 1. Example 2, I'm going to just put on the back of this same page. And example 2 is, f of x is x plus 1 times x plus 3 squared times x minus 4. Okay, so let's find the x intercepts or the real zeros. We have x plus 1. That will give us an x of -1, right? It had an understood 1 here, so its multiplicity is 1. 1 is odd, and an odd multiplicity crosses x. Okay. The next one, x plus 3, but it's squared. So now x is -3. Multiplicity is 2. Wrote it too small. 2 is even, and so even touches the x. The last one is x minus 4. So now the x is actually a positive 4. Multiplicity is 1 again. If there's nothing, it's an understood 1. 1 is odd, and an odd will cross the x-axis, okay? Now for our y-intercept, or our constant, we're going to multiply each of our constants. 1 times 3, but I need to include the multiplicity, the 2, and a negative 4. I need to include that negative, okay? 1 is to the first power, negative 4 is to the first power. So that will equal my y. So I have 1 times 9 times negative 4, because 3 squared is 9. 1 times 9 is 9. And then 9 times negative 4 is negative 36. So here I have x of 0, y of negative 36. Here I have an x of negative 1, y of 0, x of negative 3, y of 0, and then x of 4, y of 0. Now we need to find our leading term. Just like for the constant, we multiplied the constants. For the leading term, we're going to multiply the leading terms. So I have one x to the first, I have an x to the second, and then I have another x to the first. So that will become x to the fourth, right? A positive x to the fourth. So my end behavior, I'm looking at a, x, n, right? If a is greater than 0, it goes up to the right, okay? If a is less than 0, it goes down to the right. If n is even, it goes in the same direction. So they would both go up. And if n is odd, they go in different directions, or opposite would be better. So it would be going down and up, or up and down, okay? So if we look at this, our a is positive, so it's going up, because it's an understood 1. 1 is greater than 0, so it's going up to the right. 4 is even, so it is same direction. So we have an up here and an up here. All right. Ooh, and our turning points. Our turning point are n minus 1. So for that we have 4 minus 1 is 3. We have 3 turning points. So we have 3 turning points. We know it is going, the end behavior is that it is going up, and that they are going in the same direction, okay? And that it's going to cross here, touch here, and cross here. Now we use this information to graph. Negative 36, negative 1, negative 3, and 4. All right, so we have a negative 1, 0, and it's going to cross. Negative 3, it's going to touch. 4, it's going to cross. Negative 36, I'm just going to call it way down here. Okay. And it's going up in the same direction. So I'm going to be going up here, and I'm going to be going up here. So let's just draw what we can draw. Touch, comes back up, crosses, goes all the way down. We're going to turn it around down there, cross it up here, and send it up. So this is my graph. Let's see what Desmos has to say. It looks similar enough, right? I have a small turn right there, and then I go all the way down to negative. It crosses y at negative 36, and it goes even further. Goes to almost negative 160. Comes back up, crosses at 4. All right. So that was example 1. Let's go on to example 2. So example 2, part A, we have f of x is x times 1 minus x times x plus 3 squared. All right, I know this one looks different. If it looks different, you can either set it equal to 0. Setting it equal to 0 was what we did for this one. And then we just solved it and got negative 1/3. Or you can switch it around. Okay, right now, if you would like. So I can rewrite this as negative x plus 1, just because I like to see the constant at the end and the leading term at the beginning. X plus 3 squared. And then this one we also need to change, because I want you to think about, it's a factor and it has a real 0. So what real 0 could you subtract from x and still get x? What is a number you could subtract from x that would not change x? It is 0. Okay. So I'm going to the first step is to rewrite this so that I can understand it much better. All right, then we're going to find our, just the same as we did last time, we're going to find our x's. So our x-intercepts, or our r's, real zeros are x minus 1, or sorry, x minus 0. So x is 0. The multiplicity is 1. 1 is odd, and odd crosses. I have negative x plus 1. This one I'm going to set equal to 0 and solve. So now it's negative x equals negative 1. X equals 1. Multiplicity also of 1, which is odd, which will cross. And then here we have x plus 3 squared. X will equal negative 3. It'll have a multiplicity of 2. That's even, so it will touch. Okay. Our y-intercepts, or our constant, is going to be 0 times 1 times 3. Anything times 0 is just 0, right? So our y-intercept is actually just 0, 0. Our x-intercepts are 0, 0, 1, 0, and negative 3, 0. Okay. Now let's do the leading term. Just like the y-intercept, we took the whole numbers. Now we're going to take the x's. So we have 1x times a negative x times an x squared. So that would be negative x to the 4th. Okay. A, or negative 1, is less than 0. So it's opening down to the right. 4 is even, so they go in the same direction. And the turning points is 4 minus 1, 3 turning points. Okay, so now we know it's going to cross at 0, 0, cross at 1, 0, touch at -3, 0. That's that same point. The leading term is negative x to the 4th. So it's going to open down. Both sides are going in the same direction because this 4 is even. So if that one's going down, this one's going down. And then it has 3 turning points. So we're going to turn this into a graph. At 0, 0, it's going to cross. At 1, it's going to cross. And at -3, it's going to touch. Oh, sorry, they're both going down. I'm going to start here, just touch here, cross here, come back down. Let's see if Desmos agrees. So it crosses at -3, or sorry, touches at -3, crosses at 0, crosses at 1, goes down, and has 3 turns. Very good. All right, next example is f of x is 5x squared times x plus 2 times x minus 5. We're going to manipulate the x that is not being added or subtracted to anything and take it away from the 5 because this 2 is only affiliated with the first number, right? Unless it has parentheses. That squared only applies to the x. So I'm going to separate it from the 5. I'm going to rewrite it as 5x squared x plus 2 x minus 5. Let me just make sure I wrote that down correctly. Yes. All right. And remember, when we have an x alone, we're going to say that that's a real 0 of 0. So I'm going to rewrite that as x minus 0 squared, x plus 2 to the first, x minus 5. Okay, let's find our x-intercepts, or our real zeros. So we have x minus 0 squared. X is 0 with a multiplicity of 2. 2 is even touches. Here we have x plus 2. So x will be -2 with a multiplicity of 1. 1 is odd, so it crosses. And we have x minus 5. X will be +5 with a multiplicity of 1, which again crosses because 1 is an odd number. Let's do our y-intercept, which is also our constant, by multiplying all the constants together. So we have 5 as a constant. We have 2 as a constant, and we have -5 as a constant, okay? Oh, and sorry, and we have 0 squared as a constant. So 5 times 2 times -5, but times 0 squared is just going to give us 0, right? Because no matter what, if you're multiplying it all by 0, it becomes 0. So our y-intercept is 0, 0. An x-intercept is -2, 0. And another x-intercept is +5, 0. Okay? Let's talk about the leading term. For our leading term, we're going to multiply the 5, the x squared, the x, and the x. So that means we have 5x to the 4th as our leading term. Since 5 is greater than 0, it is opening up. Since 4 is even, it is the same on both sides. And the max number of turning points is 4 minus 1, which is 3. Okay, so we have the points 0, 0, -2, 0, and 5, 0. Because this is a 5, it's going to open up. This is a 4. They're both going to go in the same direction, so they're both going up. And the most turning points we have are 3. Let's graph this. 0, 0, -2, 5. Okay. All right. At 0, 0, it's going to touch. At -2, 0, it's going to cross. And at 5, 0, it's going to cross. It's going to go up and up because this 5 is positive, and it can have 3 turning points. So it's going to cross here, come up and touch here, and cross here again. That is 3 turning points, 1, 2, 3. That is both sides going up, and it is crossing at -2, touching at 0, 0, and crossing at 5. Let's see what Desmos has. They cross at -2, touch at 0, cross at 5. It's very steep, steeper than mine, but we got all the points. We got the correct number of turning points, and we got the correct direction. All right, last example. Example 3. F of x equals -2, x minus 1 squared, x squared minus 16. All right. So f of x is -2 times x minus 1 squared times x squared minus 16. Okay, I want to rewrite this. This is a difference of 2 squares because we have minus, we have a perfect square of x squared, and we have a perfect square of 16. So the square root of x squared is x, and the square root of 16 is 4. So this is a difference of 2 squares, and I'm going to rewrite it in its factored form because that is easier to find the zeros. -2 times x minus 1 squared times x plus 4 times x minus 4. Okay, so here are my x-intercepts, or my real zeros. I have x minus 1 squared. That gives me x is 1 of my zeros. My sorry, my multiplicity is 2, that's even. An even multiplicity touches x. Here I have x plus 4. So x equals -4 with a multiplicity of 1. That is odd. So that crosses. And this has x minus 4. So that's an x value of +4 with a multiplicity of 1, which is odd, which crosses. Those are my x-intercepts. So I have 1, 0, -4, 0, and +4, 0 as my x-intercepts. For my y-intercept, or my constant, I'm going to multiply -2 times -1 squared times +4 times -4. Okay, so now that's -2 times 1 times 4 times -4. That becomes -2 times 4 times -4, which becomes -8 times -4, which becomes a +32. So 0, 32 is my y. And I'll do my leading term. My leading term will be the -2 multiplied by the -1 squared multiplied by 4 multiplied, oh, sorry. I was, goodness. All right, the leading term is -2 times x squared times x times x. So that becomes -2 x to the 4. -2 is less than 0, so it opens down. 4 is even, so they go in the same direction. And then 4 minus 1 is 3 turning points. Okay, so we're going to touch at 1, 0, cross at -4, 0, cross at 4, 0, cross at 0, 32. The graph is going down to the right. They're going in the same direction. So it's both beginning down and ending down. And it has 3 turning points. So let's see if we can graph this. I guess over here. I don't leave myself a ton of space, but it's okay. It's just a tall one because we have to get up to 32. All right. At 1, 0, it'll touch. At -4, 0, it'll cross. And at +4, 1, 2, 3, 4, it'll cross. It's gonna cross the y-intercept way up here. And it starts down, ends down. Okay. So it's gonna cross, come up, go all the way up to +32, come back down, touch, turn, cross. I have 3 turning points, 1, 2, 3. It goes down in the same direction, and I cross at -4 and +4, and I touch at 1, and I cross y at 32. Let's see what Desmos has. Very hard to see. Let's go, oh, here, we'll go to 32. It crosses at 32. It crosses at -4, it touches at 1, it crosses at 4. That matches our graph. So that was just how to use the information we learned in 5.1 to graph functions of polynomials. Great work, and I will see you next time.